Assalamualaikum viewers, and welcome to the second video of your integration by parts. And in this video we are going to discuss the example in which the integrand is somewhat different, like what we discussed in the previous video while dealing the two examples. So let's have a look, because in the previous video if those who have watched, they might have they have seen over there that in the integrand in the examples, the integrand that we used out there were quite fixed, because in those integrands which were expressed as the product of two different functions, one function was the one whose only derivative exists and the integral was not possible, and the other one was obviously that's the reason why the function whose only derivative exists and the integration was not possible, you just took it as your f of x, and the other function was obviously taken as the g of x. But over here in this example that we are going to discuss in this video, the case is somewhat different. Let's have a look at this question over here. Okay, here you go. This is the example. Now let me just write this constant 2 outside the integral to make the integrand much soft looking, I must say. So this is it. Now this integrand, which is so expressed as the product of two functions. One function is the polynomial, another function is the exponential. So you see this function is expressed in terms of x squared. So how about if I simplify this integrand by help of substitution? First of all, let's give a shape to it. So how about if I just write this integrand, though I can handle this integrand directly as well, but if I simplify this integrand before performing by parts with the help of the substitution method, it'll become more much better for us and more and easier for us to understand. So and the learners will further come to know that we can fuse the substitution while performing integration by parts. So how we fuse how we just paste the substitution method as well while performing the by parts. Let's have a look. Let's split this x cubed in terms of x and x squared like this. Okay, now let us perform the substitution. If I just assume that let my x squared is my u, perform your u substitution. Conventionally call it u, otherwise you can take any other variable for substitution you want. So let x squared equals to your u. Okay, then just differentiate both sides with respect to your x. Comes out to be performing the formula of derivative of xn is n times x power n minus 1. So it comes out to be this, and it is du by dx. This dx will go over there. So 2x dx gets too messy. I hope you understand that. So it is 2x dx equals to your du. Alright, so it means that this thing can be written like this: a 2x dx will be replaced by your du, and this x squared, the place of my x squared, just write u, and e power u and 2x dx will be replaced by my du. Okay, now this integrand, which was this, has been simplified in this form. Now you can see that still the integrand is expressed as the product of two functions, and none of the functions expressed as the derivative of the other. Now you're going to apply the by parts. Now the question arises that which function you are going to take as your f of x, the function to be differentiated, and which function you should take as your g of x, the function to be integrated. So you can see if you take this u as your f of u, then it is going to get perished. I mean, it's going to convert it into 1, and the integral is going to come to its end soon. But if you take u as your g of u over there, then in that case you see it is difficult for you to handle, because it becomes u squared by 2, and then you take the integral of your u squared, becomes u cube upon 3, and so on. So you see the u is not going to come to its end. Its power will keep on increasing on and on and on. So the by part's not going to come to its end. And you know that exponential is a non-ending function. Its derivative is also the same exponential, its derivative, and the integral of this function is also the exponential. So this function is a non-ending function. It's not going to get finished. But the polynomial is concerned, it can come to its end if you take its derivative instead of taking integral. So just take this function, make a decision, and take this function as your f of u, and this function just take it as your g of u. All right. So now we are going to perform the by part. So let's write the formula in terms of u. And I've elaborated this formula already in the first part of this of the video. Then I don't think so that I have to repeat this thing again. So I'm directly writing the formula for you. And okay, so this is it. That's the formula. Now let's, as we have just made the decision that u is our f of u, the function to be derivated, and e of u is taken as the g of u, the function to be integrated. Okay, so let us make a proper column here. F of u is our u, g of u is our e power u. Differentiate both sides with respect to your u. So f dash u is just 1, and integrate both sides with respect to your u. This comes out to be your g of capital G of u, and it is your e of u as it is, or some constant. So now f dash u is 1, g of u is e power u plus some constant, and now you're going to substitute these answers in this formula of your by parts. Let's highlight this thing. Okay, so now let's write the original function. And it was simplified in this form. Try to be very precise in your work. And now apply the by parts. You see that integral of f of u g of u du, which is this is f of u g of u du, and it is equal to your f of u capital G of u, and f of u is what? It is your u, g of u is your e of u. Just write it, minus integral f dash u is your 1, g of u is e of u. So it is 1 and e of u. No need to write the constant here because the process is going on. That's it. Okay, so integral of eu is eu itself. I'm sorry, it's nothing. So plus some constant. Okay, now you're going to restore the original variable. You know that you just assume that your x squared was your u, so just restore the original variable. So there you go. You can take out e power x squared, and these two terms is common outside. Plus some constant. So this is the answer of this. The integral of this integrand comes out to be this. Okay, by performing the by parts. You can see here, I repeat, that you just fused the substitution process here, and then you notice that still it is expressed as the product of two functions. The integrand is expressed as the product of two functions, and none of the function is expressed as the derivative of the other, so you perform the by parts, and then you decide which function you're going to take as your f of x and which function you should take as your g of x, by noticing that the polynomial part of the integrand should be taken as your f of x, because it is going to get perished after performing the repeated steps of your by parts. So that's how you do. In the same way, if you are having an integral in which the integrand is expressed as the product of polynomial and a trigonometric function, and polynomial and a logarithmic function like that, that in that case, how you are going to deal and which function you should take as your f of x and which function you should take as the g of x, we are going to discuss in the coming problem. So let's have a look. So here you go, another example. Over here you can see that the integrand is expressed as the product of two functions, out of which one is the polynomial, another one is the trigonometric function. So I told you that whenever you are having an integrand as the product of a polynomial and a non-ending function, like if it is a polynomial and a trigonometric function, always take the polynomial as your f of x, the function to be that you have to differentiate by performing the by parts. And if you're having an integrand which is expressed as the product of a polynomial and an exponential like that, always take the polynomial as your integrand, as your f of x, and exponential as your g of x. This is the function to be differentiated, this is the function to be integrated while performing the by parts. And if you're having an integrand mentioned in the question, which is the product of a polynomial and a logarithmic function like that, then always take the polynomial in that case as your g of x and logarithmic function as your f of x, because you know that the integral of this function does not exist, so obviously you have to take it as your f of x, the function to be differentiated. Okay, and if you're having a polynomial and a trigonometric function product, then always take the polynomial as your f of x and this one as your g of x. And if you're having an integrand, one more thing, that's though it is quite understood, but I think I should mention this thing as well. If the integrand is expressed as the product of an exponential and a logarithmic function, something like this, whatever, I'm just giving you an options. So you are going to take obviously this function as your f of x, and this one is going to be your g of x. Okay, so remember, you can notice here that if you're having a polynomial and your e of x, take polynomial as your f of x, and if the polynomial is expressed as in the integrand as along with logarithmic function, then take logarithmic function as your f of x and polynomial as the g of x. Okay, but just keep these tips in your mind. All right, so now let's have a look, and over here you can see that you're having a sine square x here and polynomial. So polynomial is definitely going to be taken as your f of x, a function to be differentiated. So how you're going to handle this thing? Let us simplify this sine square x, because I don't like the sine square x over here. So as you know that the formula of your double angle cosine, which is cos square x minus sine square x. Yeah, so if I just write this cos square x as your 1 minus sine square x, it comes out to be your 1 minus 2 sine square x. Okay, so your cosine of your 2x equals to 1 minus 2 times sine square x. If I just shift this minus sine square x over here and cos of 2x over here, it comes to be, it should look like this. Okay, so sine square x can be expressed as this. Okay, so how about if I replace my sine square x with this function at this place? Let's see how it looks like, and it will become more convenient for us to handle such questions. Okay, so let's do. Alright, so now this 2 is going to come out. It's going to be taken outside the integral, and now it is okay. Now you just multiply your x squared with these two terms one by one, and it is going to appear like this. Okay, that's it. Now you're going to apply your integral individually on this term of the integrand and this term of the integrand one by one. So let's draw a square bracket here. Integral of your x squared d of x minus integral of your x squared cosine of your 2x d of x. Okay, it's done. So now you can see that this integral can easily be handled by simply applying the formula of your xn. Over here, the integrand is expressed as the product of two functions. One is the polynomial, another one is the trigonometric. So take this function of your f of x and this function of your g of x. Over here in this integral, you have to apply the by parts. Okay, so excuse me. Out to be 2 plus 1 upon 2 plus 1. Over here I've just applied the integral, and I'm going to copy this integral as it is because I have to apply the by parts. Okay, and x cubed upon 3 minus integral x squared cosine of 2x d of x. But let this be our equation number 1. For convenience, I've just named this equation as my equation number 1. Okay, this is it. Now I have to apply the by parts over here. Okay, now let's see. Take f of x as your x squared and g of x as cosine of 2x. Okay, I have to integrate this part, I have to differentiate this part, and then we are going to solve this integral. So let's see. Okay, I have simply picked up this the segment of this equation, or our previous equation number 1, and now I'm going to solve it with the by parts. So you can see that this function is my column. This function is your f of x, the polynomial part of your f of x, and my g of x is going to be taken as a trigonometric function. Now just differentiate both sides. So now I'm going to do it directly. The differentiating both sides, I'm having 2x, okay, and the integral of this function, when I integrate both sides with respect to my dx, I'm having g of x. And though I can apply here the substitution process, I can substitute 2x by my u, and then I can do the integration. Also I can do the simple integration directly by just taking this as okay, and in the denominator I am going to take out the derivative of this angle of cosine as some constant. Okay, the answer comes out to be 2. Let's see. Okay, so you can perform this integration by means of substitution, by substituting 2x equals to u, and then you can carry on your work, and also you can do this directly because this angle of cosine was quite simple. That's why I prefer to do this thing directly. And now you see your g of x is right over here in front of you, and your f dash x is over here. So let us highlight. We have just highlighted these two functions. Now let us write down the formula of our by parts. Okay, so this is our f, this is our g. Okay, now f is our x squared, g is this, write it down, 1, 2, minus integral of my f dash x is 2x, and my sine of 2x is, g of x is sine 2x upon 2, plus no need to write the constant, just write d of x because the process is going on still. So this and this 2 and this 2 will get cancelled. Now you are having now still in the integrand of this integral, you can see that you are having two functions. One is the polynomial, another one is the trigonometric. So now take the polynomial part once again, your f of x, and sine 2x going to be taken as your g of x. Once again apply the by parts. So now take this f of x as your x, g of x as your sine of 2x. Okay, you just apply that, you just differentiate both sides with respect to your x. You are now going to have your 1, your f dash 1 is now f dash x is now your 1. Just highlight, and once you integrate both sides, okay, so it is going to be your g of x, and integral of your sine is negative cosine of this angle upon the derivative of the angle plus some constant. Okay, so let us make column here. So your g of x comes out to be negative cosine 2x upon 2, negative cos 2x upon 2, some constant. This is your g of x now. Okay, so now over here at this place you're going to apply the by parts. So let us do it. X squared sine of 2x upon 2 minus sign over here, and in the integral part you are going to apply this formula once again, because this time your f of integral of your f g dx is going to be expressed with this formula. So let us open a big bracket here for convenience because you're having a negative sign outside. So over here your f is x, your g is this. It's going to be minus x cos of 2x upon 2 minus integral f dash x is your 1, g of x is this. Now we need to write 1 because it is understood into dx, and you then close the bracket. Okay, now it is, let's open it up. Let's open it up, and you see minus minus give you plus. And you see minus minus is plus, and then this plus minus give you minus. Okay, and this 2 I'm going to write outside the integral, and it's cosine 2x dx. Let's apply now it is a simplified form. This is the integrand is expressed just by the one function. So simply put down the formula of your integral representing your cosine, and you are done. Okay, the integral of your cos is sine of the same angle upon the derivative of this angle, which is 2. No need to write again and again, so it is understood. So that's it. So now finally, you can see here that 1 upon 2 is coming common in all these 3 terms. So just take it out. And I can write it as x squared sine of 2x plus x cosine 2x minus sine of 2x upon 2. Alright, plus some constant. So this is the answer of this integral. Now you're going to put the answer of this integral in your equation number 1. Let me just this was your equation number 1, yeah? This was the equation 1. So over here we have just evaluated the answer of this integral, but we are going to substitute over here now. Okay, so as the space over here is quite narrow, so how about if I use a different page? So let's see. So you see this was your equation number 1, so I've just written over here. Okay, x cubed upon 3 minus, and now you're going to write the answer of this integral that we have evaluated here. There you can see I've just placed the answer of our integral of this one that we have done at the back by parts. So that's it. So you can keep your answer over here, it's also correct. Also you can multiply this half with these 2 terms, and in that case it looks like this, nothing else. And if you are in mood to open the parentheses, then in that case this negative sign is going to change the sign of the terms inside the parentheses, and that's the maximum change you can bring in your answer. So, and once this half gets multiplied with this c, then it's going to become c upon 2, and that's also a constant, so you can write it simply by c dash. So that's the answer of this integral, okay, by means of about by parts. This was a quite long question, but I hope you have learned how to handle such kind of questions. So keep the tips in your mind and practice the questions as much as you can, just to enhance your grip. And if you feel that the concept of by parts dealing in such cases as the product of polynomial and trigonometric function, and the product of your exponential and polynomial, and the product of your exponential and logarithmic integrands, if you feel that you are now a little bit clear in handling such kind of questions, then I appreciate it. Please subscribe my channel and just hit on the like and share this video with your other friends and learners, so that it's going to be more and more dispensed and people can get healed with it. Take good care of yourself. I'll see you in the future with more helpful videos. Allah Hafiz.